Hi, my name is Rishikeshan and I'm from DAM1A, and we are going to do our first presentation for Engineering Mathematics 1, and our topic for the presentation is trigonometry.
Hello, my name is Taiji Wei, and I'm from class DAM 1A, and my message number is 24 DAM 22F 2012. Thank you.
Hello madam, my name is Modhan and I am from class DAM 1A. My matrix numbers are 24 DAM 22F 2003. Thank you. Today I am going to explain the introduction of the trigonometry. The word trigonometry is derived from Greek word. For example, tri, gon and metron. The meaning of the tri is 3 and gon is side and metron is measurement. Trigonometry is a three-side measurement. For example, hypotenuse, opposite, and adjacent. Trigonometry is a study of relationship between length, height, and the angle of a triangle. I am going to talk about Pythagoras theorem. Pythagoras theorem states that the square of the longest side of a right angle triangle, for example hypotenuse, is equal to the sum of the squares of the other two sides. For example, if we want to find one side of the right angle triangle, for example hypotenuse, we need to plus the other two sides with square and then square root the answer to get the final answer of the hypotenuse. Now I'm going to explain the trigonometry formula. There are three types of formula. So firstly, sin, cos and tan. Sin theta equals to opposite over hypotenuse and tan theta equals to opposite over adjacent and cos theta equals to adjacent over hypotenuse. There are another simple method to remember easily the methods on. They are so, cha and kwa. Now I am going to explain the trigonometry formula. There are four types of quadrant. So quadrant 1, secondly quadrant 2, quadrant 3 and last one quadrant 4. Quadrant 1 is all positive. For example, sin theta, cos theta and tan theta. Quadrant 2 is only sin theta is positive and quadrant 3 is tan theta is positive and quadrant 4 is only cos theta is positive.
Trigonometry formula. Let's see the third one. Sine rule. Two angles and one side are given. Two sides and one included angle are given. The formula for sine rule is A over sine A equal to B over sine B equal to C over sine C. And then the fourth one is cosine rule. Two sides and included angle are given. Only three sides are given. The formula for cosine rule is A square equal to B square plus C square minus 2BC cos A, and also cos A, B square plus C square minus A square over 2BC.
Okay, now I'm going to explain about the application of trigonometry in engineering. Engineers routinely use trigonometry concepts to calculate the angles. An example is the calculation of a static force on an object that is not moving. Engineers use trigonometry to decompose the forces into horizontal, vertical, and components that can be analyzed. For example, like maybe aircraft, they normally fly like this, right? And if they want to turn around, like this, turn around, and we can see that the aircraft is flying like this, and if they want to turn, it's impossible to turn it like this because they are not vehicles that we drive every day. They also have the inner shell, and they are in like 3D the three dimension of flying when it flies. So if you turn it like this, it will the pilot will use the control column to control it, the aileron, to give the plane roll a bit, and then after that they pull the elevator, and then to leave out the pitch, to give it a pitch out a bit, and then so they can turn it. But when they turning, they need to know the way that it goes. So how do we know the arc of the plane that is turned? But by using trigonometry in this situation, they can use, but they can use it like this because at the at the first thing the aircraft they roll a bit, right? So when you roll a bit, you can see that here's have a bit angle, right? So we can use the trigonometry to calculate the length of it. So and then we can get the length from the center part of the turning point to the center of gravity to the aircraft. And then we can calculate the arc of the turning section to the aircraft. This can avoid collision from other planes because if they know the way that the aircraft turn, and they can avoid it to crash on it. So this is an help of trigonometry in engineering by avoid collision of many aircraft that flying up the sky today. Okay, besides of that, engineers also need to understand the forces at work on an object. This is critical part of statics, which is essential area of engineering. The study of the statics and the related calculations are used by engineers to ensure the buildings and bridges will not collapse due to the force acting on them. For examples like bridge, you can see this is a rebar, right? And this is the bridge, right? And they also have to measure the cable from here at the top here to the bridge there to measure the length of it, so they will know how long that the cable that it needs to hold the bridge to avoid the collapse due to the force acting on them. So this is a very good example of trigonometry by using in the civil engineering platform like that lah. So now let's move on. For an example question is about Bob is a mechanical engineer for auto mechanics. He is designing the trunk of a sedan car and is now focusing on the trunk door. The max angle of the door can open is 50 degrees and it will rise up to 30 cm. What's the length of the door for the trunk? So let's see about here. As you can see that this triangle, we can use some trigonometric method to solve it, to find what's the length of it. And how are we gonna use? First thing, we can look at the first formula that we told. Okay, so it's about the Pythagoras theorem, and we can see that in that formula we need two sides of information at least, but as you can see that there's only one, the 30 cm only, this one, it doesn't have the other one, so it means that we can't use this formula. But besides that, is it that given us a 50 degree, so that means that maybe we can use the three other one is sin, the other is cos or tan. But which one are you gonna choose? Let's see here. Okay, now we have the opposite side, right? And now what are we gonna find? We're gonna find the adjacent side, right? So what formula we're gonna use is TOA is 12. So this means that we're gonna use tan. So we're gonna use tan equals to opposite side divide by the adjacent side. And now we will convert the values into the formula. So is tan 50 equals to 30 cm divided by x, because the x is the thing that we need to find. and the x is equals to the adjacent, the length of the door for the trunk. And how we gonna find? First thing, you can draw the x to the opposite side, so and then you pull the tan 50 towards to the down of the 30, so it will become like x equals to 30 cm divided by tan 50, because before that is 30 cm divided by x so when we draw it to the opposite side, divide becomes to become to times, so it means that actually we in front of the tan 50 we also have 1, but we didn't write it out. So now is 1 times x, but 1 times x is equal to x, right? So we didn't write it about the 1, so we just write it as x at there. And then at here is 1 times tan 50 right before, and then we convert to the opposite side of the equals and becomes to divide. So now we can get x equals to 30 cm divided by tan 50 though. And then we can proceed by using calculator by entering the values like 30 divided by tan 50, and then you will get 25.17 cm. That's all. Thank you.
So let's see about how trigonometry used in mechanical engineering. In mechanical engineering, trigonometry is used to calculate torque and forces on object, but it is also used to find displacement and figuring out an object dimension. They can also use sine bar. Sine bars are tools that measure angle in metalworking. For the example, we have a sine bar picture on the left of the slide. So, and finally, we are heading to the conclusion. The conclusion for this topic is trigonometry is a very useful tool for engineering, especially mechanic, that helps you solve missing problem for triangular structures and invention, and can demonstrate how to design by using the correct formulas.